I believe that software freedom, at its heart, is not about the licenses, not even about the code. It's about power. The power struggle that exists between, in some cases, the large corporate developers. In some cases, there is no struggle because we're all on the same side, the developers and the users. And it's about who has it, who doesn't, whether there's a struggle or not. And in this power struggle, we as free software activists are the resistance. The powers I am most familiar with are those of the graphics industry where I work, and that will be the focus of the talk. To understand the powers here, it's necessary to understand a little bit about how GPUs work and what that means for us in free software. There are generally two types of graphics hardware. Discrete GPUs, you can just go out and buy a GPU, plug it into your computer, and use it. And in this case, you can pick the one that works with free software drivers, pick the one work with your game, whatever. That's one set of issues. The more tricky set for us are the integrated GPUs, the ones that come as part of the computer you buy and that you never get to swap out without swapping out the whole computer, or at least the whole system on chip. And for this, it's crucially important that we have excellent free software support for these graphics parts. Because if we don't have graphics acceleration. And that's not just a problem if you're trying to play video games. You need graphics acceleration today for even pedestrian things like web browsers, video players, even your desktop environment. If anyone here runs GNOME or KDE, you're going to be using your GPU for that. So it's not having graphics working on GNU Linux would not be a great thing. So what is the challenge here? Well, there are a lot of different companies that make GPUs, and even for each company that makes a GPU, they make lots of different GPUs that require vastly different software to program the GPU. We have, on the desktop side, we have Intel, AMD, and NVIDIA all making graphics hardware with 3 very different architectures. On the mobile side, we have even more vendors: ARM, Qualcomm, Broadcom, Vivante, Imagination, Apple, and I don't think I forgot anybody, but I might have. There are way too many. And we have a combinatoric problem here, right? Your graphics software, Super TuxKart, whatever, needs to know how to talk to the GPU. The GPU needs to be talked to in some very obscure arcane language specific to only it. Maybe, hopefully some stuff is shared with other GPUs from the same vendor, but certainly not across vendors. And so we have this combinatoric nightmare. How do we make it so any software, Super TuxKart, Super Tux Ball, all the Super Tux games, how to make them all work on any GPU? Well, we have 2 components. The first are we need graphic standards. Instead of every vendor having their own different way of talking to graphics hardware, we have a standard. For decades, the big graphics standard in the free software world was OpenGL. Today, we're moving towards Vulkan. The non-free software world has Direct3D as their standard implemented by their set of vendors. Today, either way, a developer, and today, Windows has Direct3D and OpenGL and Vulkan. GNU Linux has OpenGL and Vulkan, and with the layered DXVK and VKD3 Proton projects, we also have Direct3D. So pretty much within these standards, any developer implements their application to target the standard, whichever standard they pick, and the hardware vendors all implement that standard for their hardware, and so you have your driver, and everything just works. And that means the user can run any application they want, on any operating system they want, on any computer they want. And that is user freedom to me. The licenses play a big part in this, but ultimately, being able to swap out those parts, that's what the standard is good for here. So where does the vendor that I left off in that list? Well, let's talk about Apple. um, Apple has, well, Apple has a proprietary operating system. They have proprietary drivers for their proprietary operating system. They have their own graphics standard implemented by nobody but them, controlled by nobody but them. For the record, even Microsoft doesn't have such an ironclad grip over Direct3D as Apple has over Apple's own metal, which is why I will begrudgingly refer to Direct3D as a standard, if not the one I would prefer as a free software activist. But Apple's thing, very much not a standard. So anyways, Apple has proprietary OS, proprietary drivers, their own API, and now they have their own proprietary hardware that they don't have documentation for, so nobody else can write drivers for. And they only supply drivers for this hardware as part of their proprietary operating system with their proprietary graphics standard, which means if you buy an Apple hardware, you can only run on it software that was specifically ported to run on the Apple hardware, and vice versa. If you're a developer, you want to run your software on Apple, well, tough luck. You'll have to go out of your way to work on that Apple hardware, and all the code you write for that won't run on anybody else's computer, whether it's running Windows or GNU Linux. And that's not great for a developer. That's not great for a user. The proprietary OS, the drivers, the vendor API, these are the walls of the walled garden. And when we talk about the walled garden, this is what I'm talking about. So what do? How do we escape the walled garden? Well, we take these walls and we have to break them down. Instead of a proprietary operating system, we're going to run GNU Linux, even on our MacBooks. Instead of proprietary drivers, we're going to write our own drivers, and they're going to be better than theirs. Maybe. I'm a little biased. Instead of having this corporate standard, we're going to implement real standards, OpenGL and Vulkan, and Direct3D if you want, with the free software Direct3D on Vulkan layers. And this means we have portability. It means that a user can take their ThinkPad X200 running GNU Linux, and they can run the exact same thing on a MacBook. And if they decide they don't like it, well, they can go back to the ThinkPad, and it's all interchangeable. It means the games that they want to play from whether they were originally written for Windows or for Linux, they can run it on their ThinkPad or on their MacBook or whatever, and they have that total choice. Choice of software, choice of hardware, that to me is a very real sense of software freedom that goes beyond just what license is the code under. Obviously, I would prefer if you're running GNU Linux, but I try to harm reduction as it is. So how do we actually do that? Because Apple doesn't publish specifications for their hardware, and the specs they do publish is just how to use their proprietary API to write code for their proprietary system. Well, that's when reverse engineering comes in. We need to figure out how this hardware actually works. And this is not a particularly technical talk, so I don't want to go into too much detail about the witchcraft there. But if you are interested, I have given talks in full witch costume. Got a hat and everything and a wand, and yeah. But the basic idea there is that we can write a little bit of code to spy on what the proprietary drivers do. And we just treat it as a big black box. We don't want to go disassembling it or anything, because then if we do that, we have copyright issues trying to write our own drivers. But we're just going to treat it as a big black box. We know we can put in we can put in our own test applications, our test inputs in, run it through the driver, and see what comes out, what registers it programs in the hardware, what binaries it compiles for the shader cores, and so on. And we can do our witchcraft tricks, wave our magic wand, and bit by bit build up a model of how the hardware actually works. And once we've reverse engineer it, well, we can write our own drivers as part of the upstream Linux kernel, as part of Mesa 3D. We can implement OpenGL on this chip. We can even implement Vulkan on the chip, even though Apple refuses to. And we did. As of this past February, we now have a conformant that is industry recognized, standards compliant, conformant OpenGL 4.6 support, which is the full OpenGL spec. For the record, Apple does not ship conformant OpenGL, and their GL driver, the non-conformant one, is stuck at 4.1. So that's pretty cool. Beat them there. Thank you. How did we do that? Well, they're trying to build this thing from scratch because they're inside their own walled garden, whereas we have the Mesa 3D project, which implements OpenGL 4.6 and has been implementing OpenGL for 30 years. So all we have to do is add our little bit of applesauce to it, and poof, we get Apple 4.6. No, that pun was not intended. And Apple's excuse for not implementing the new versions of OpenGL on their hardware is that they claim that OpenGL is deprecated. I think their lawyers would tell you that OpenGL is deprecated on macOS. Okay, I'm not a lawyer, not going to read too much into that. But first of all, OpenGL is not deprecated. On life support, maybe, but not deprecated. And in so much as it is deprecated, the replacement is Vulkan, the new industry standard for graphics. And as for Vulkan on your Macs, well, we'll talk about, you'll hear about that soon enough. Wink, wink. So in this quest to escape the walled garden, be able to run full GNU Linux, full graphics acceleration with completely free drivers on hardware that was not intended for any of this, will I be successful? Will our very small, underfunded team be able to free this chip? Well, I don't know. Actually, in my notes for this, I have a little shruggy drawn out, but kind of hard to convey. Oh, wait, that's where the shruggy comes from. There we go. I don't know. Apple is a tremendously large corporation. I am under the impression they have hundreds of engineers doing what we have a team of 2 part-time people working on. And they are one of the richest companies in the world, whereas I split my rent with my roommate. But I'm not demotivated. And for that, I want to go back in time and tell a story of how I got into this in the first place. I want to talk about when I got my first Chromebook. I was 15, and I was involved at the time with the LibrePlanet project, and I was very interested in being able to run computers with full free software, something which, and I will take a moment to acknowledge that the bootloader is completely proprietary software and a nightmare. I do not endorse using a Mac if that's what your interest is, but I do think it's important that we have free software support for the systems nonetheless, because the reality is that there are people that will be buying Macs and will want to run GNU Linux sometimes later, and I don't want them to be stuck to a VM for that. At any rate, I got a Chromebook, and at the time, this Rockchip RK3288 Chromebook was the newest machine that was supported by LibreBoot. Not only that, this machine could be used with not only a completely free bootloader, but also a free embedded controller firmware and no microcode. Whereas the ThinkPads of the era still required proprietary EC firmware, still required microcode. In a very real sense, this ARM Chromebook could be more free, or at least better for free software than the X200 that Stallman was using at the time. And I thought that was pretty interesting. I thought that's where we should be going. There were only 2 problems with it. The first problem was Wi-Fi, the perennial problem. It needed a firmware blob. But that's not a big deal. You can get a little AR9271 USB dongle, plug it in, and get on with your day, and have get Wi-Fi in your Linux Libre kernel. The real problem was the GPU. It had this ARM Mali T760 GPU, and it did not have free software drivers for it. And ARM's official position was, here's this blob. It is not very good for what you care about. It has no source code. You're on your own. Stick to Chrome OS. I don't know. Stick to Android is, I think, the idea at the time. I don't actually know if that's what. I don't speak for ARM. Please don't sue me. But I was 15, and I had all of the humility of a 15-year-old You know what I'm talking about. And when somebody told me that the reason why this couldn't be done was because you have to be an expert in GPUs to even make an attempt at this problem, I thought, expert schmexpert. And so I started reverse engineering this blob. Was very bad at it at the beginning. I should get that out of the way. But eventually, I drew a triangle, and then 2 triangles. And you know what you can do after you draw 2 triangles? You can draw a square. And, you know, within a few months, had, you know, spinning cube. I think a year later or so, I had GNOME running, which was my real interest. I wanted to run GNOME on this Chromebook. Runs, for the record, GNOME still doesn't run very well on that machine, but not for GPU reasons. But finally, I was making progress on this. And this was supposed to be the impossible problem. And this meant that this hardware went from being worse for freedom than the contemporary machines to possibly better. And I just remember being in high school and realizing I did this. I made a change in the world. There are 7 billion people on this planet, and nobody else was going to do this if I didn't. And that was, I think that moment for me was pivotal, because nobody else was going to do this. There are lots of people that jumped on to support things once the project was kicked off. I did not do this whole effort by myself, not even close. But you know, they had a level of risk aversion that I, as a 16-year-old with no sense of sanity, did not. And I don't know if you've seen the stack of dominoes meme, but somebody once commented to me that they were picturing the stack of dominoes starting from Alyssa gets a Chromebook to the $30+ billion ARM Corporation publicly announces their support for free software ARM GPU drivers. At the time, I had no idea what we were in store for, but I no longer work on the ARM GPU drivers because we succeeded. ARM backs the project. There are contributions from @arm.com emails to the free software ARM GPU drivers. You can get that Rockchip 3288 Chromebook, install Debian or Fedora, whatever you want on it, and have everything work without blobs out of the box, including full GPU acceleration. GLES 3.1 support. We won. and there's, from what I understand, a commitment to continued support for free software on the ARM platform. So, you know, just check off that whole vendor from the considerations of who do we have to fight. So, okay, moved on to the, I guess I'm going alphabetically, moved on to the next A vendor. Kidding, not even alphabetical. But thank you. Thank you. But the thing is, this is not a talk about GPUs. It's not even a talk about software, which is ironic for somebody who just spent the past 10 minutes talking about GPU software. But I know. But this is a talk about individuals with very little resources, all things considered, fighting back against giant corporations that with massive amounts of money behind them. This is a talk about grassroots resistance. And the thing is, I don't care if you run Windows or if you play Mario Kart or whatever. What I care about is that you're resisting, that you're part of the community, that you're doing whatever it takes to fight back against this. Because the fact is, free software is under attack from very powerful forces, and our struggle matters, and we need you, all of you. And I'm not saying you have to go out and reverse engineer GPUs. I think we've run out of vendors to reverse engineer. I mean, if you'd like to, I'm happy to have the help. But whatever your cause is, whether it is free software in some sense, whether it's labor rights against fighting back against surveillance capitalism, whether you're a pacifist, whatever it is, at the end of the day, we're all on the same side here. There's only class struggle. And what I want you to do is find your lever. For me, what I found was that I am weirdly good at reverse engineering GPUs and writing drivers. Okay, cool. That is a lever I have. I can push a little bit on one end, just me, and I can get a lot out of progress against the big corporate monolith. pushing on one end and getting a lot back out the other. And that's what's key to all of this. As a community, our small good actions can cancel out massive bad ones from the bad actors in our spaces. And so your job is to find those levers. I guess I got lucky with this one, stumbled into it. I hope you can be more deliberate about it in your worlds, whatever it is that you're fighting for personally. I do want to advise that the goal here is not to push so hard and just to the point of passing out. Because if this is a contest of brute force, you trying to just write more software than they can, you trying to beat them on features, whatever it is, you're going to lose on brute force. That's a reality. They have far more headcount, far more money, far more legal status, even, unfortunately. But you can work smarter, and you can work together, and you can do the right thing. You can win hearts and not clients. You can make friends and not sales. Because the reality is that each one of you in the audience, you have something that the corporations do not. You have integrity, you have passion, you have altruism, you have community. You have the ability to see things and care about things other than next quarter's profits. Things that the people that we're fighting against literally do not at a structural level. And what I want from each of you, in whatever circle it is, whatever it is you're doing, whether it's GPU or reverse engineering or unionizing tech workers, whatever it is, I want you to find those levers. I want you to find those abilities that you have. I want you to build those communities, and I want you to resist. Thank you. I believe there's Q&A now.
I think it's pretty clear from the standing ovation that you just received that we're all really grateful for your talk. It was so beautiful. And it makes me really excited, almost to tears, to see a young person like you so motivated. And I just want to say a big, big thank you.
Thank you.
Yeah, and I'm speechless otherwise, so thanks.
Thank you.
I want to say that I completely agree with the second half of your talk, and I think it's something very important for us to remember that, like, a lot of us when it comes to agency and pulling those levers, that's a lot of how we get this done. But I guess I wanted to ask, as like someone who's like been involved in these projects and like I guess been leading these projects, how do we go about like identifying talent and then like creating structures whereby we can identify them and like really bring them into the fold to really like get things done and really not just, I guess, like go from like necessarily recognizing the problem, which we are doing right now, which is good, but then also really creating structures which will encourage, like necessarily incentivize us to begin developing like those levers.
Unfortunately, I don't have an easy answer there. Like I said, I guess I stumbled into what I did.
Fair enough.
And I did not get to this planet set out to do free software graphics drivers. If it were up to me, I think I would be in climate activism, quite frankly. But this is what I'm really good at, and I guess I'll stick with it. I'm sorry that I don't have a better answer, honestly.
Okay, and I guess then one other quick question. How long did it take between the process of you being able to draw that triangle and when you first started out?
Let's see. I started poking at things over the summer of 2017. Mm-hmm. After August, I took the rest of the year off because, high school and all, and got back at things in January of 2018, and I think we had a triangle up in February.
Okay. Nice.
At that point, that would have been using shaders that were pre-compiled by the proprietary driver, and it wasn't a driver at that point. It was basically a memory dump that we were replaying, but that's how it starts.
Yeah, makes sense. Thank you.
Hi. First, I just want to say amazing talk.
Thank you.
Just wonderful work that you do.
Thank you.
So I was wondering, from your opinion and experience, do you think that hardware, say hardware vendors, so the companies that actually create the hardware, like the say SoCs, the chips, are do you think that they're directly fighting back against this movement? And if so, how so?
So it's going to depend on the vendor. In general, corporations are not your friends. They can be your allies, but they're not your friends. There's a range of opinions on software freedom among hardware vendors. I don't think there's anybody who is setting out to crush it necessarily, but I don't think there's anybody that necessarily shares our ideological views at the management level. And so what you're finding, there is a tendency that I see among certain like GNU Linux users to say, oh, AMD's the good guy, NVIDIA's the bad guy, rawr. And I don't think that's necessarily warranted because how those companies behave is very clearly the result of their current market circumstances and so forth. Like I said, we can have allies, but not friends. Enemies might be too strong of a word in many of these cases. I think what Apple has done with leaving the table on the graphic standards entirely, I think that is a very grave sin, and in some ways far more than NVIDIA publishing their Vulkan driver, but only as a binary blob. Which, by the way, you don't need anymore. Shameless plug for NVK. Mesa now has full support for Vulkan with free software on current NVIDIA hardware with reclocking. There is a firmware blob, but not my work, just plugging it.
Sorry, that brings me to one more question.
Yep.
Do you think that it is actually beneficial for any of these hardware companies to say open source their chip design via Verilog code? Would it actually, do you think, be beneficial for any company to do that?
For the company or for us?
For the company, like, would any company in the future, do you think, actually do that?
I don't think so. So I guess I have a two-part answer. One is I don't think so because that for these companies that is their secret sauce. Intel has their own fabs. Intel does literally have the hardware business, but for all the other hardware vendors, they're just doing the chip designs and then paying TSMC to actually fab them out. And what that means is that their Verilog code is their secret sauce.
Yeah.
Asking them to asking them to publish their Verilog code is exactly the same as asking Microsoft to publish the source code for Microsoft Windows. Which would be super cool if it happened, just for the record.
Exactly, yeah.
I'm not opposed to that.
That's why I was curious, like what you thought about that.
But the second part of my answer is that it doesn't matter as much. The reality is that, if Windows were free software, there are lots of things that Windows users could do that they cannot do now, and that there are very real freedoms that are being denied by not having Windows being free software. And there are very real advantages that users have running something like GNU Linux as a result of that. The same cannot be said for the hardware IP. It would be really great to have the Verilog code, but as a user, there's literally nothing you can do with it because just being able to fab out a chip is millions of dollars, right?
Yeah.
And you can't run these GPUs on an FPGA because there are not consumer available FPGAs big enough to run any
Yeah,
serious
not powerful enough.
workload.
Yeah. Okay. Thank you very much.
Sure.
Hello. You just say that when trying to use free software with Apple hardware, we still need to use a USB dongle to use the Wi-Fi. And I wonder, is there any hope to free the modern Wi-Fi chips which supports Wi-Fi 5, 6, or 6E?
So the comment I made about the USB Wi-Fi dongle was for the Chromebook, where that was the one other blob. With Apple, there are lots and lots of firmware blobs, unfortunately. And honestly, some of the firmware blobs on Apple are scarier than the stuff that, you know, in some ways, some of the Apple blobs are scarier than the Intel management engine, and I'll leave it at that. But maybe that's just because I've had to write code that works with them. In general, it's my understanding that there are issues with free software wireless firmware that are not purely technical, but I don't really want to make a statement on that because that's not my area. I do know that, you know, the FCC does not care if you have free software graphics drivers. I'll leave it at that.
Okay, thank you.
Sure.
Thank you very much for that talk. I know it's a few steps below A, but Intel's management engine does seem like something that if we could reverse engineer it would be a game changer. But I am curious, what is the difficulty level of that? How does that compare with reverse engineering a GPU? And is it so difficult that maybe it's actually easier to get away from x86 altogether?
Again, this is not my specialty. I've been running exclusively ARM chips since I was 15 now, per the talk. I joke that I make a joke that I'll only run computers if I wrote the graphics drivers for them, and I must have started working on Apple because I got tired of my slow Chromebook. Not an accurate history, but far funnier than the real one. That being said, it's my understanding that the management engine has challenges that are not purely reverse engineering related. I think there might be like signature checks on that or cryptography or something. That would be a question for somebody who works in Intel stuff, which is not me, thankfully.
So you talk about this, all these efforts that you've been making to work on getting code running on these graphics drivers. This seems like a very similar, it seems like it should be on the surface, very similar to how on CPUs we have innumerable different architectures, maybe not so much anymore. Do you have any thoughts on why we see such a big difference in running code on the CPU and on the GPU in terms of difficulty and the barriers specifically in getting free software to do that?
Sure. So there are a number of differences here. The first is that GPUs are not just there is a lot of fixed function hardware in a GPU. It's not just running your shader code. What makes a GPU interesting is that it has this massively parallel CPU-like architecture, but it's also wrapped around a fixed, very fast rasterization hardware, texturing hardware, and so on, which means that so this is good because it means you can do 3D graphics at shockingly low power envelopes and with good performance even on tiny little cell phones. But it does make the driver side much more complicated because it's not, all of those different fixed function pieces need special driver support for them. And if you ever looked at the Vulkan spec, it's like 5,000 pages. It's because there's all this random fixed function hardware that we need a way to drive. So that's problem one, and challenge one. Challenge two is that GPU instruction sets are, on the whole, far more diverse, far more variable, and far more exotic than CPU instruction sets. What do I mean by that? Well, modern CPUs have all converged on basically the same design. You have relatively simple instructions, and they just do things, load, store, arithmetic, that's it, end of story. And they have backwards compatibility for decades. I realize that's a sweeping generalization that barely applies to x86, but let's be real. But by contrast with GPUs, the instruction sets are not considered public in the same way. It's not the hardware vendors don't expect anybody to write a compiler for their hardware other than themselves, so they can make it as bizarre as they want, and they can make it change from chip to chip. You know, a, sh- a, bi- a program binary that runs on the M1 may not run on the M1 Pro, right? That's how unstable these things are. So there's that. So and the designs themselves, because there is that freedom, you get all sorts of weird designs. I have personally worked on compilers for hardware that is completely vector, so like SIMD based. I've worked on hardware that is very long instruction word architectures, you know, and so on. There's Bifrost, which has clauses, and I can't even begin to explain what a clause is because after having written a compiler for it, I still don't really know. And you just don't see that sort of complexity on the CPU side. So putting that together, it means that you have very different challenges. I'm not saying that writing a C compiler for a modern CPU is easy. By no means, it is very challenging, but it's challenging for very different reasons than the GPUs. And there are just very few. And I think the biggest thing then is just we have approximately approximately two instruction sets that I have to care about. There might be some RISC-V and PowerPC users out there, but basically in this room, I think there are about 4 instruction sets that we care about for modern computers. There are over a dozen GPU instruction sets we care about.
I see. Thank you very much.
We have a few questions online. So during your work, reverse engineering drivers, what resource do you find most helpful to learn about these things?
The source code for other free graphics drivers. I'm very lucky that I was not the first one on these problems. The hardware vendors all like to think that they have the most unique special sauce ever, but the reality is that none of them really have any special sauce, and they're all kind of doing the same 4 things that everybody else did last year. And reading through other drivers as inside Mesa 3D source code is incredibly informative to see how old hardware works and current hardware works, and by extension, how future hardware probably will work.
Someone asked about what about proprietary firmware packages? They say I think all dedicated GPUs require them, but correct me if I'm wrong.
Yes. So unfortunately, we see sort of on one hand we're going up in that the graphics drivers have over time become more free on the CPU side, both kernel and user space. On the other hand, we're also seeing more firmware blobs. So in that sense, we're going down for software freedom there. It's my personal opinion that the GPU firmware blobs are not a huge deal as far as, I mean, it's not ideal. I'd rather not have them. I'd rather them be free software. But there are good technical reasons why we have the firmware in the first place, and they're not threats to freedom in the way that a proprietary driver for a proprietary API is a threat to freedom. So maybe that makes me a pragmatist. I don't know. But also, if you want to go reverse engineer GPU firmware blobs, 2 thumbs up for me.
Just while being amazed at what you've done, and I think it's quite an accomplishment. And I'm wondering, it's easy to see why the software vendors would be threatened by open software, right? Obviously, that's pretty obvious. But I'm just wondering, why do you think the hardware ones are? I mean, why would somebody like ARM or whatever, wouldn't they want to have as much software written for their platform as possible, right? So I'm wondering what their motivation is to stay closed, other than Apple. Apple, that's a different story.
Right. So
obviously.
Putting aside Apple with their world concern, it's not so much a threat and more a. They don't share our ideological views for the first of all, so they don't see any impetus to have the software be free, and the default is unfortunately proprietary software in this industry. At least it was. Today we've turned that tide. You know, Intel's drivers are all free software and upstream, which is amazing. AMD's drivers are all free software. They're not upstream for the Vulkan side. That's a whole nother story. That's a whole nother conversation. NVIDIA has finally come to the table. It took a long time to get there with them, but they're finally come to the table, at least a little bit. And, you know, in the past couple weeks, if you look at Mesa 3D, there are commits coming in from @nvidia.com addresses and that are sanctioned. That's pretty cool. So I guess my answer to why are they threatened is these days they're not. But I think years ago there was just a lot of sense that, you know, open source was for loonies. And okay, great. I'm one of the loonies. We won.
Thank you. Very inspiring, Looney, though. So thanks a lot.
Thank you. We're still going.
So sticking with the topic of hardware vendors,
Yeah.
are you, when they decide basically to go to open source or free software drivers,
Yep.
were you involved in some kind of discussions with them? Did they approach you and say, hey, you do great work, how can we implement this? Or,
With ARM, you mean?
for example?
I don't know how much I'm at liberty to speak publicly about. I will say, I was not the one at the negotiating table, but my work was definitely one of the chips that was used on the table. And I think I'll leave it at that.
On the last one, still in the same idea of how you approach these things, someone asked, what's the first thing you did when you got started with reverse engineering the Apple GPU?
The Apple. So for the Apple, I already knew more or less what I was doing because I had ARM under my belt. So what I knew that what I needed was a way to intercept the communications between their user space driver and their hardware. And the way to do that in general, well, on Linux, the way I would do that is I would read the code for the kernel module, and which are all going to be a free software because the GPL says it has to. That's great. And so I would read that, and I'd start instrumenting that way, figure out how it talks to the hardware, how it submits, and then I would write a little library that I could LD preload in to spy on it, basically. Dump memory, do whatever I want. On macOS, didn't have that luxury because the macOS kernel is proprietary. The kernel driver is also proprietary, and there's no GPL, meaning that it has to be. So we have that sort of double challenge. Not only, which is bad for two ends. It means that one, we have to reverse engineer the kernel driver, which I'm very grateful that my colleague Lena did, and we have to write our own kernel driver, but we had to do that anyway. But it also means that we don't know even how to intercept the communications because we don't know what we're intercepting into. And so I think the first thing I did was I started reading up on how Apple device drivers are structured, and they have their whole I/O kit system. Their whole thing is C++ based, object-oriented. I have my aesthetic differences, so I started reading up on that. I started figuring out how to intercept things in a macOS way. The answer turned out to be that instead of where we have IOCTL, they have a bunch of different standard library methods, IO connect call method, blah, blah, blah. And so I did the same thing I would usually do. I wrote up a bunch of stubs for all the different IO connect methods and added my tracing in there and dialed insert libraries it. And suddenly I could get memory dumps and could start figuring out, okay, here is how it allocates memory. Here is how it submits command buffers. So then I can start dumping memory and dumping command buffers. And, you know, I remember staring at a just gigantic, I just took a big memory dump, dumped it all as hex, and just was staring at it. It was just looking, okay, here's an address, here's a color, here's a number, and so on, and just started piecing together things. And the big thing is that as soon as you figure things out, you want to start writing code to automatically pretty print things, because you don't want to start hex dumps the whole time. You want to be able to make progress, iterate forward. And so you get you start writing your decoded code, and you go from having piles of hex dumps to having some C structure definitions with lots of random hex values in there, and you start turning those random hex values into bit flags, and you start identifying enums, and you start picking out values, and just breaking up the problem and going from giant hex blob to what you eventually get, a C header file with enums, and that's something you can start writing a driver from. Also, I drew a triangle at some point in there, I don't know. It's very easy. You just take a pencil and you go like this. And,
your work is amazing and your talk is inspiring. I just want to know that after you published the free driver, what's Apple's reaction to that? Thank you.
I don't know, tried to hire me? I can only speculate about how Apple views our project and our work. They have not done anything to impede us. They have not done anything to try to shut us down, thank God. I don't think they're threatened by us by any means, because and why would they be? I'm not losing them any business. If anything, on a semi-regular basis, I hear people saying, I'm buying my first MacBook because of how great the GNU Linux support is. I'm like, well, I don't know if I recommend that, but okay. From a business side, I suspect that our work is a net positive for Apple, if anything. That being said, they will not lift a finger to help with documentation or anything like that, which is unfortunate, makes my job way more fun. So, realistically, I don't expect to see the sort of position reversal with Apple that we saw with ARM, just because the corporate politics involved are so different, the market positions are so different. ARM never had a walled garden the way Apple has today. ARM just needed to be shown the light, as it were.
I think we're at time. Please thank again our speaker.